Hello people, welcome to Gurukula. I'm Jay. So today in this video we are going to talk about the topic CSMA CA, which is Carrier Sense Multiple Access Collision Avoidance. So now without any further delay, let's get into the topic. Whereas in our previous videos we were talking about the access control mechanism which is getting deployed at the data link layer, and we have seen what is access control mechanism, and we are currently discussing on what are all the various types of access control mechanisms that we have. Out of various classifications of access control mechanism, currently we are discussing about the access control protocol, and we have completed discussing the Aloha, CSMA and then CSMA and then CSMA CD. So here in this particular video we will be talking about what is CSMA CA. So just to understand what CSMA CA is, we should try to differentiate how CSMA CA is getting differentiated from CSMA CD. So let us assume with a small example that, let's take for an example, then this is an highway or a road from which a person who is standing over here wants to cross from this side to this particular side. So in case of CSMA CD, what will happen? This particular person will sense for the channel for a particular instant of time t1, and then if there is no vehicles coming on this particular road, he will immediately start crossing the road to the other side. So this is the principle that we will follow in CSMA CD. So whereas in CSMA CA, it is clearly seen that it is a topic that is talking about collision avoidance. So here what we will do is we will have to avoid the occurrence of collision itself. Whereas in CSMA CD, the frame will be sent on the channel and then it will be continuously monitored whether it is undergoing any collision or not. But whereas in CSMA CA, we are trying to avoid the collision. So how is it avoiding the collision? Let us take the same scenario again. So we have an highway like this, and a person who is standing over here wants to cross the road from this point to this particular point. So what will happen is, as far as CSMA CA is concerned, he is not going to sense the channel only for a particular time period t1, but instead he is going to check, or is going to sense the channel for a period of time. Let's take for an example, not only for one instant, not only for that particular instant he will check, he will also continuously monitor the channel for 100 microseconds or 5 seconds, let us assume for example concern. So if there is no vehicles coming on this particular road for the entire duration for which he monitored, then what he will do is he will immediately create a barrier, a temporary barrier, so which will defer any vehicles coming on this particular road. And once assuring that the way is completely blocked, and then this particular person will start crossing the road from this point to the other point. So this ensures that there is no possibility of collision in the data transfer. So this is a key principle or a little bit of example that we can keep in mind so as to understand what exactly CSMA CA is concerned. So with this example, we will try to understand what exactly CSMA CA is. So here we will see what CSMA CA is. So in CSMA CA, the station senses the channel only for that particular instant, and then it decides the idleness of the channel. But that is not the case in CSMA CA, whereas the station is going to sense the channel over a period. So when we say period, then definitely we should have certain amount of timers, or we should have some special timers to take care of this period, to count this period. So these timers is what we call it as NAV, that is network allocation vectors. So there are two different types of timers or important timers which we have to understand for understanding the principles of CSMA CA. The two timers are DIFS and then SIFS. Whereas DIFS stands for Distributed Coordinated Function Interframe Space, and SIFS is nothing but that is Short Interframe Space. So we will see what these two timers are and where these two timers will be used in the functions of CSMA CA. So as far as DIFS is concerned, this is the time period for which the station is going to continuously monitor the idleness of the channel. And if the channel is found to be idle for the entire period of DIFS, then we can say that the station can transmit its message. So that time period is what we call it as DIFS. And whereas on the other hand, we have short interframe space, we call it as SIFS, and this is the amount of time which may be in microseconds, which is required for any station to process the received frame and to respond. So the time taken for a station to receive a frame, to process a frame and to respond the frame is what we call it as short interframe space time. So now we will try to understand how this CSMA CA will work with the help of a flow diagram. So first of all, before sending a frame, the source station senses the channel for a period of DIFS. So we already know that. So DIFS is the period for which the station is going to sense the channel for its idleness. So see, for an example, here is the source station and here is the destination station. So what happens is, before sending any data, the source is going to sense the channel for the period of DIFS. And if the channel is found to be idle, then the sender sends a control frame, that is what we call it as RTS. And your RTS is nothing but request to send. And this request to send signal is nothing but a source is asking a destination that I have some data to transmit, can I send it now? So that is a request which is sent from the source side to the destination side. And what happens at the destination side? You can see that the frame is being received by the destination, and then the frame is being processed, and then the frame is responded back with an CTS signal. And whereas CTS signal is nothing but clear to send, but before getting into CTS, you can clearly see that the time taken to receive the frame, to process the frame and to respond to the source is what we call it as SIFS. So the destination station will take a time period of SIFS to respond back to any frames that is received from the source signal. Now coming to the CTS, CTS stands for clear to send, which means that destination is saying to the source that I am ready to receive all the data whatever you are going to send. So by the meantime, you can see that before the source station is sending the RTS signal, all other stations are deferred in transmitting, or all other stations is deferred to access a particular channel. So now making this, what will happen? Only the source and then the destination is going to exchange its information, and no other nodes is going to access the channel, so that there is no possibility of collision that is occurring in the entire period of transmission and then the reception. So that is why it is what we are calling it as collision avoidance. So we are taking sufficient steps to avoid collision rather than detecting the collision as opposed to CSMA CD. So once CTS signal is received from the destination, the source station will take again a period of SIFS. The SIFS is nothing but the time taken to receive the frame, to process the frame and to respond to the frame. So once it is identified, or once the source node receives the clear to send, then the source station will start sending the data over here. So all the data will be sent, and then all the data will take some time to get processed, and finally the destination station will send an acknowledgement signal to the source station. So once all these stations have been done, no other stations will be allowed to use the channel during this particular period of time. So that is where CSMA CA is getting deferred from CSMA CD. So now we will try to understand the entire flowchart of this particular CSMA CA is as similar to CSMA CD what we discussed in the previous videos. I will try to leave the link in the description section and as well as in the I button. So please do check the description video of CSMA CD if you have not watched it yet. So this flow diagram, there will be only difference that it will have to wait for a timer, whereas in CSMA CD we will be checking the channel only for that particular instant, but whereas in CSMA CA we have two special timers, and except these timers the working principle will be almost similar to CSMA CD. So when you look at this particular block diagram, let us assume that a channel See, say for an example, a station has a frame to send, and as usual initially the number of attempts is initiated to 0, and then what I have to do, I will have to check for the channel idleness. So carrier sense process is being happen, so I will be keep on sensing the channel, and then I will have to wait for interframe space period, and this interframe space period is what we call it as DIFS. So I am going to sense the channel for the period of DIFS, and then once it is done, I am going to choose a contention video. Contention window is nothing but it is any random value r which lies between 0 to 2 to the power k minus 1, and you might have seen this expression in CSMA CD also, whereas it is used to calculate the back of time period. So it will have to choose a random value r, and then the sending node will send an RTS, which is nothing but your request to send signal. So once after sending RTS, then again a timer will have to be initiated, and this timer will be set to SIFS period, and then you can see that I will have to wait for the CTS signal, which I should receive the CTS signal before this timer gets expired. So if I get CTS signal from the destination, then I can send the frame. The transmission and reception will happen as usual. These two nodes will be keep on exchanging the nodes from one point to another point. So next you can see that in case if we don't get, in case if we don't get any CTS signal from the destination, then you will have to increment the value of number of attempts to 1, and then we will have to check whether we have already reached the maximum number of attempts, and if not, we can retry again the entire procedure, and in case if we reach the maximum number of attempts, then we will have to abort the transmission, assuming that there is a permanent failure in the network. So as you can see, the CSMA CA workflow is as similar to the CSMA CD, and the only difference is the time periods that we are including over here. And it is important to note that only these are the timers which is making the difference, and also it is making all the steps to avoid the collision in the network. So that's all about this particular video. So today in this video we were talking about the access control, and then we were talking about the various principles that is behind the access control mechanism, and especially under random access method we spoke about Aloha, CSMA, CSMA CD in the previous videos, and today in this video we have completed discussing CSMA CA. And a point to remember over here is that a CSMA CA is widely used access mechanism in wireless LAN is concerned, and whereas your CSMA CD is widely used access mechanism in your Ethernet, which means your wired connection. So all the wired networks will be using an access method of CSMA CD, and all the wireless networks will use an access mechanism that is CSMA CA is concerned. So I'm going to stop my video over here, and I'm going to see you in the next video. Until then, it's bye from Jai and happy learning.